Hello. For this example, we're going to look at the antiderivative rules for transcendental functions and then the antiderivative rules that also involve transcendental functions, right? So involving and then also including. So we do know two things. We know that a rule that we learned earlier in the semester when we were learning derivatives is that the derivative of natural log of x is equal to 1 over x. Another rule that we know is that the derivative of e to the x is e to the x. Well, when we think about reversing and finding these antiderivatives, when we look at this first example here, we've got the integral of 1 over x dx. Remember, integrals are reversing antiderivatives. So reversing that, the integral of 1 over x dx is natural log of the absolute value of x. And then because this is an indefinite integral, we haven't learned anything about bounds yet, we're going to make sure that we always write plus c on the end. Furthermore, I think it should make very good sense to us. The integral of e to the x integrated with respect to the x is e to the x, again, plus c. Now, if we were dealing with the derivative with respect to x of any base a to the x, finding that derivative would still be a to the x, but we multiply by natural log of the base. So that's a derivative rule. When we integrate, we end up dividing by natural log of the base. So for example, the integral of 5 to the x integrated with respect to x dx is 5 to the x over the natural log of 5. And then of course you would write plus c. Now we do have a few trig functions that involve transcendental derivatives. You don't need to know these just yet, but you need to be familiar with them because they will show up in your homework and you can reference your textbook and notes for that. But moving into Calculus 2, the next sequenced course, these are rules that we generally considered standard and that we know how to deal with when we see them. And in fact, when we get to section 5.5, U substitution, we learn to derive using U substitution the integral of tangent x, which is natural log of the absolute value of secant x plus that c. So let's look at two basic examples. Just make sure we can use those rules that we showed up above. So for the first example, remember, one of the main things that we have to do in calculus is to rearrange the problem so that it looks like something manageable. Well, times 3 is a constant multiple. Remember, the constant multiple can come in front of that integral symbol. And I'm left with 1 over x times dx, that variable of integration telling us to integrate with respect to x. We treat that like its own little variable and it can slide out to the back. And so here you can see that this is equal to 3, and then the integral of 1 over x, which we discussed up above, is natural log of the absolute value of x. And then, of course, we write plus c. So it's just that simple. It's just a rule that you need to know. Furthermore, when we look at this next example here, 2 to the x plus 5 tangent x minus 1 over x dx, 2 to the x plus 5 tangent x minus 1 over x. That's 3 terms. So by linearity, we can rewrite this, and I can write this as the integral of 2 to the x. Notice that the entire integrand is in parentheses. The dx is going to distribute to each of the 3 terms. So the next one is the integral of 5 times tangent x. 5 is a constant multiple. I can write that in front of my integral symbol. Again, this one also gets a dx. And I have minus negative 1 in front of that, being a constant multiple, 1 over x dx. So I'll integrate each of these. The integral of 2 to the x is 2 to the x divided by natural log of the base, which is 2, plus 5 The integral of tangent x, again, you don't have to have this stored just yet, and eventually you'll know how to develop it without the rule, but it's up here. It's the natural log of the absolute value of secant x. And then again, the integral of 1 over x is natural log of the absolute value of x. And are we done? Almost, but not quite. We have to write plus c because this is an indefinite integral. So these are some basic examples just using the rules. You're going to see some of the rules in your homework, but you're not going to see a lot of these problems just yet. Later in the semester, when we learn more about U substitution as a strategy for solving integrals, we'll see a lot more integrals that involve natural log of x and e to the x. And remember, the only integral rule that we didn't address is that the integral of e to the x dx is e to the x. And then again, indefinite, no bounds, we put a plus c. So I hope that clears this up. You just want to make sure that you know these rules and you know how to use them, just like you know all of your trig rules for antiderivatives and your power rule for antiderivatives. Let me know if you have any questions.